Coking is a carbon rejection method achieved through the severe thermal cracking of heavy hydrocarbon feeds, most typically vacuum resid feeds. The rejected carbon takes the form of petroleum coke, which is then calcined in further steps to remove entrained hydrocarbons. The coke product directly from the coker is called green coke. Carbon content can be further increased by calcination at temperatures between 1800 and 2400 degrees Fahrenheit or 980 to 1315 degrees Celsius. The three main types of coking processes available to the petroleum industry are delayed coking, flexi-coking, and fluid coking, all three of which will be discussed later in the video. Delayed coking, which is the most popular method, involves the feed being charged to the bottom of a fractionator where it is refluxed against hot vapors entering from the in-service coke drum. The fractionator bottoms are then sent through a fired heater to a large coking drum at a high velocity, which shortens the residence time in the horizontal heater tubes and delays the bulk of the coking reactions until the drums are reached, hence the name delayed coking. A stream of heavy coker gas oil is condensed while the remaining vapors are cooled and separated into gas and liquid products as they ascend through the fractionation tower. A generalized diagram of the delayed coking process is depicted in this figure. Coke collected in the drum have three general categories. Needle coke exhibits microscopic anisotropic particles and evolved from processing aromatic feedstocks at high pressures greater than 100 psi gauge or 690 kilopascals and high recycle ratios, such as 1:1. Sponge coke is characterized by irregular particles ranging from 50 centimeters or 1.64 feet down to dust. It is typically produced from low sulfur, low metals vacuum resids. Shot coke is usually an unintentional product when processing very heavy residual feeds. The particles can exceed 20 centimeters or 0.66 feet, but are not a useful product as the particle surface areas are much less than sponge coke, and they do not have useful characteristics for manufacturing electrodes like needle coke. The coke in the drum is used for fuel. The manufacture of anodes for electrolytic alumina reduction. As a carbon source for the production of elemental phosphorus, calcium carbide, and silicon carbide. The manufacture of electrodes used in electric furnace production of phosphorus, titanium dioxide, calcium carbide, and silicon carbide. The manufacture of graphite and is feedstock to a gasifier for utilities and/or chemicals production. In flexi-coking, the coker feed is preheated between 600 to 700 degrees Fahrenheit or 315 to 370 degrees Celsius and injected into a reactor to be contacted with a hot fluidized bed of coke. The hot coke provides enough heat to vaporize the feed and drive endothermic cracking reactions. The reactor temperature is maintained between 950 and 1000 degrees Fahrenheit or 510 to 540 degrees Celsius by adjusting the feed rate of the hot coke that comes into contact with the feed. Cracked vapors travel upward in the reactor and pass through cyclone separators to remove coke particles. The top of the reactor is typically scrubbed with wash oil, which condenses some of the heavier hydrocarbon components, sending them back into the reaction zone. The wash oil also reduces the amount of entrained coke particles in the gas product. The new coke produced from the cracking reactions will deposit on the hot coke particles, which are stripped with steam before flowing out of the reactor to the heater where coke particles are heated in a fluidized bed to 1100 degrees Fahrenheit or 593 degrees Celsius. The coke not recycled to the reactor flows further to a gasification reactor to react with air and steam at temperatures ranging from 1500 to 1800 degrees Fahrenheit or 816 to 982 degrees Celsius. The product fuel gas consists of predominantly carbon monoxide, hydrogen gas, carbon dioxide, and nitrogen gas. This hot gas is then recycled back to the heater to be used as a heat source. The coke gas from the heater exits from the top before passing through a waste heat boiler. The stream is further purified through external cyclones and a Venturi wet scrubber before being sent to the sulfur recovery unit. Flexi-coking designs are capable of gasifying 60 to 98% of the coke produced in the reactor. The coke gas has a heating value of 100 to 130 British thermal units per standard cubic foot, which is much less than the 900 to 1000 British thermal units per standard cubic foot obtainable from natural gas. Fluid coking is a simplified version of flexi-coking and is similar to the FCC process in many aspects. There are typically two vessels, a fluidized bed reactor with a steam stripping zone and a burner vessel. In the burner vessel, only enough coke is combusted to meet the heating requirements of the endothermic cracking reactions. The remaining coke, typically 75 to 80% of the total, is withdrawn from the burner. The coke yield from a fluid coker is typically 75 to 80% of the coke yield for a delayed coker. Flexi-coking yields 240% of what a delayed coker yields. Here is a non-inclusive list of companies that license commercial coking technologies.